Today we are continuing the discussion of solving things, but now we're doing inequalities. So things that are not equal or necessarily equal. Alright, so this is section number 5. Solving inequalities. Now you've had this explanation of inequalities several times before, so I'm just going to hit it really quickly. Let's say that I start with this: 4 is less than 5. That's an inequality and it's a true one. Let's test adding. I can add 1 there, and I get 5 is less than 6. I'm good, so I can add to both sides. And if I subtract, start with the same thing. 3 is less than 4. Yeah, that's good, so I can subtract both sides. Let's say multiply. Let's multiply by a positive. Let's multiply by 2. Alright, we get 8 is less than 10. Yeah, that's okay. But then, when I multiply by a negative, say negative 2, I get negative 8 is less than negative 10, and uh-oh, that does not work. So that's a problem. So whenever we multiply, this is the important thing to remember for today. Whenever we multiply or divide by a negative, whenever we do that, we are going to switch the inequality. And for short, I say flip it. So we flip the whole inequality. So I should flip that one around to say negative 8 is greater than negative 10 because I multiplied right here by a negative. Now it doesn't matter if my answer becomes negative in the process. It's whether I multiplied or divided by a negative. So let's start with just a couple of simple examples. So if I had x plus 5 is less than 3. And the next step to solve this would be to do what? Subtract 5. And then I do that on both sides, and I get x is less than negative 2. And you might think, oh, I got a negative over here. I should flip this. And no, we should not. We only flip the direction of the inequality if we multiply or divide by a negative. Because of the reason, okay, so I start with 4 is less than 5, and that's a true thing. And let's just say for some reason I multiplied both sides by a negative 2. For whatever reason, I'm doing that. I multiplied by a negative. It doesn't matter what the negative is. This becomes negative 8. That becomes negative 10. Negative 8 is not less than negative 10, so I need to change the direction of the inequality. So that serves as an example of why when I'm solving these, like if I had negative 2x is greater than 10. In order to solve this, I would divide by a negative 2. Because I divide by a negative 2, I need to remember this situation and flip that around. And something inequality, I switch the direction of my inequality. It flips around because of this. And it doesn't matter which numbers I use in this example, it's always going to be the case that whenever I multiply or divide by a negative, I need to end up flipping that around. So that's, in a nutshell, the main thing that you need to remember for solving inequalities. For the most part, they work the same as equalities with that exception. But then there's 2 other things that we need to go over in order for us to be good and actually do the questions that we need to be able to do. And that first thing is going to be compound inequalities. That means they're going to have 2 parts. And we have 2 kinds of compound. We have conjunction, and we have disjunction. A conjunction, our key word is going to be the word and our symbol is like a upside down V. And in disjunction, our keyword is or, and our symbol is going to be a V. It means or. And depending upon the situation, you might see, just so that we talk about it, this symbol means intersect. This symbol means union. So those are similar, but for the most part, we'll have these. Or I think your book actually uses the actual word there. So conjunction and. So I'm going to use Lila as an example. So if I said Lila is a girl and she can fly without the help of a plane, would you say this is a true statement or a false statement? Well, you would say false. Let's not overthink it. It's false. Yes, she's a girl, but no, she cannot fly. Okay? She does not have that ability. So this is a false statement. So a conjunction, both things need to work. Both things need to work. So hence we are going to look for overlap in our answer, and we'll do an example of that in a moment. But let's say, using the same example, I have Lila is a girl. Well, that's true, she's a girl. Or, now I have the word or here, she can fly. Flip, she can flip. Yes, she can do that too. She can fly. Well, yeah, she's a girl, but no, she can't fly. I mean, just because I switched or, it doesn't change whether she can fly or not. But I would actually say that this is a true statement. And this is true because she is a girl. That's true. She can't fly, but yes, she is a girl. It's like or one of these or both of these. Basically, is that the case? So I'm looking for, well, not necessarily overlap. I just want whatever's true. So when I go to do my disjunctions, I just want to be able to express my answers in the simplest way possible. And that's where the trick's going to come in. So we're going to discuss that trick. So conjunction, remember overlap, and with just disjunction I think of I don't need overlap. I don't need it. I can have it. I don't need it. So I'll say don't need overlap. Let's use some graphs to figure out how these simplify down. So I'm going to use this. So here's my number line. Okay, and I'm going to do a bunch of these. So we'll do a bunch of number lines. And I don't want to take forever to get this set up. So let's say in the process of solving, I have a conjunction and I say x is greater than -2 and x is less than 1. In the process of solving, I get that. So x is greater than 2. That's going to be an open circle, and I would go to the left. And x is less than 1, that'd be an open circle. And notice, because it's and, I look for overlap. And I see that they overlap right here. So the simplest way to write my solution, and for whatever reason, I don't know why students get this so confused. What's the smallest number here, where the overlap is? -2. That should always go on the left. And the 1, which is the largest number of my answer, should go on the right. And then x is going to be between these. Well, -2 isn't that less than 1? So I do this. That should always be the final form of my conjunctions, is this. Sometimes, and inevitably, every single year, I say this, and every single year, a student still does it. This is crazy talk. Do you see this? Wrong. Here, look at it. if you write something like this and those are going opposite ways, 100% guarantee I am marking this wrong. Okay, that is not correct. They should be pointing the same exact way. All right, so any questions on that example? All right, here's another form that it can take. So I'm going to undo a bunch of these. Okay. Those go away. All right, let's try x. I solve something and I get x is greater than negative 1 and x is greater than 2. All right, I graph that. X is greater than negative 1. Here's negative 1. Open circle, go to the right. And here's x is greater than 2. Open circle at 2, go to the right. Any questions how I'm graphing that? Now where's my overlap? Do I overlap right here? Right here? Right here is where I overlap. So starting just after 2. So how could I say that? Well, x is greater than 2. I don't need to involve this piece right here because there's no overlap right there. Does that make sense? I just came up with a better solution to how to do this. Okay, so I graph those. So in the end, you need to graph these.
Wait, could you go back?
See, I have overlap right here.
Yeah, but what was the thing?
Oh, x is greater than 2. Because look where my overlap starts. It starts right here, just after 2. So x is greater than 2 is where it starts. All right? Do that, and then I just got a wonderful solution to this problem. I can do this. Okay, now I have copied that. Good. All right, so let's try x is less than negative 1 and x is greater than 3. And I graph that. With and, I'm looking for overlap. It's my friend. That's what I want. So here's less than negative 1. Here's greater than 3. And then we see after graphing this, what? Yeah, they don't overlap. So the answer is no. There is no overlap. Or we say empty set. Or we say this. Or we say no solution. Any of these will be fine answers. Okay? But if there's no overlap, there's no answer. Any questions on conjunction? Do you need any more examples of how to figure them out? No? Good. All right. Get rid of that. Okay, so let's do a disjunction. See, disjunction, or, one or the other. And this is where we get confused because we do have overlap here. But the thing is, we don't need it. Whenever I have disjunction, I look for where my graph is. Do I have graph right here? No, so no answers there. Do I have graphs right here? Do I have a graph right here? Yes, I have a plot right there. Do I have a plot right here? So my answer actually starts right here at 1. So x is less than 1 is the simplest way to write that. Okay? So for disjunction, I just look for where the graph is. No overlap necessary. And it'll be easier if I just add a new slide. So that's what I'm going to do. Next one, let's say x is less than -1 or x is greater than 2. So open circle to the left for x is less than -1, and open circle to the right for greater than 2. Again, it's or, so do I need overlap? No, no overlap necessary. So then I look here, and do I have a graph? Well, let's start on the right, just because that's what I did before. Do I have a graph right here? Yeah, so I have answers there. Do I have a graph right here, in the middle? No, no answers there. Do I have a graph right here? Yes. So what are my answers? Well, this. This is the only way to write it. I can't write it any simpler than that. X is less than -1 or is greater than 2. I can't write that any other way.
So for this, your answer will most likely be either one or both of the beginning. So these ones and
For the most part, well, I don't want to say always, because there's always exceptions.
like in the last one, it was x is less than -2 or x is less than 1, and then the answer was x is less than 1.
It just depends upon where the graph is. So the graph is right here starting at 1. There is overlap here, but it doesn't matter. So the simplest way to write that, the graph starts at x is less than 1. There is no simpler way to write this. So that was the answer. All right. Let's do one more conjunction or disjunction. Let's make that a -2. So I start at negative. Now, if this were an equal to, what would I do with my circle? I'd color it in. I haven't done any of those, but that's the only difference. All right, so if this were conjunction, I'd shade in this overlap. Now let's think. Where is my graph? Do I have a graph over here where this one is? Yeah. Do I have a graph right here where they overlap? And do I have a graph right here? I have a graph everywhere. So I say the real numbers. Everything. So I could say everything. Everything works. Okay, just to hit home the point. Now this is after you've already solved. So my assumption here is that you can actually get to the solved part. Then this is the new thing, graph it to figure out what the answer is. So to hit home the point, we're going to do 3 where we compare and contrast them. So, no, just watch. And then, so we'll have 3. And we'll see the differences. So the first question here on number 1, I'm going to do x is less than -2, and, so that's my and symbol, x is less than 3. And I'm going to compare that answer to this one. Same thing, except I'm going to switch it to an or. All right, so I'll do the blue one on top and the green one on bottom. All right, so blue one. Say they are actually graphed the same way. Here's less than. Here's less than. And if it's conjunction, if it's and, I'm looking for what? Overlap. So I have graph starting right here, right? So my answer to this one is x is less than -2, because that's where my overlap is. In green, it actually graphs the same way. But my conclusion is different. With disjunction, the or, I'm just looking for where the graph is. Is there a graph right here? Well, yes. Is there a graph right here? Is there a graph over here to the right of the 3? No. So the easiest way to answer that one is x is less than 3. Because there's graphs starting at 3. Maybe we'll just do 2 of these, I don't know. It gets repetitious. Let's say we have this case. X is greater than 0 and x is less than 2. And in green, we will do x is the same thing, except we'll switch to an or. And they'll graph the same way. Greater, less. Now if I have conjunction, I'm looking for overlap. So it's right there. So what's my answer? 0 is less than x is less than 2. See, it's sandwiched between the numbers. See, easy. This number first, this number second, and it's always going to be less than. It's right there. Very rarely do I say always. I just said always. So next one in green is going to be the same plot. But when I have disjunction, I'm asking, where is the graph? See, here I'm looking, where's overlap? Just where is the graph? I have a graph right here to the right. Right here, right. I have it everywhere. Real numbers for that one. Okay? And one more case, I suppose. I mean, we could do billions of these. Say x is less than -2 and x is greater than 1. And we'll do a green, the same thing, but an or. And they graph the same way. They graph the same way. All right? In the blue, it's conjunction. I'm looking for overlap. There is no overlap, so there is no solution. And in green, well, there's a graph right here. There's not a graph there, and there's a graph there, and the easiest way to write that is like that. Okay, so we're on to the last thing that we need to know. And if you want to get that down in your notes, that'll be online like by 4. These are conjunctions that I'm about to do. But they're conjunctions that are already put into place. So let's say I have -4 is less than 2x minus 6 is less than 12. We'll even throw an equals 2 in there just so that we can do that. Now notice I have my x in the middle and I have 2 symbols. So what I do is I pretend that I have 3 sides and I solve for x. So in order to solve for x, I would add 6, but instead of adding 6 to 2 sides, I add 6 to 3 sides. Now I get a 2. And then what would I do next? Divide both sides by 2. And that's my answer. So those typically are pretty easy. It's just remembering that you have 3 sides instead of just 2. We'll do one more of those, and then we'll just do a bunch of examples from your book so that I can know that you're good in life. I'll smush this next one down here. Nah, I'll go to the next slide. Next slide. Here we go. I guess we should do one more after this. I don't know. All right, so what should we do here? Times it by -3. And what do we need to remember to do when we multiply by a negative with inequalities? Yeah, these directions need to switch. So I get -12 is less than or equal to, and the -3 cancels. And then we subtract the 6. And I just check to make sure that makes sense. And it does. -18 should be less than -12. We subtracted.
Oh, I see.
All right, I'm going to put a couple problems up here. They actually do come from your book, but they'll be a good practice. I do want my variable to end up on the left, so let's just do a quick one where it does not let's say I have 6 is greater than or equal to 2x. How do I solve that? Divide by 2. So I get a 3 is greater than or equal to x. Now, you never want to, with inequalities, leave it like that, ever, ever, because you're probably going to graph it wrong. We always want, with inequalities, our variable on the left. So I flip it around, notice the pointing is pointing towards what? So at the very end, I just make sure it's still pointing towards the x. And then I can see how that should graph. Now, I will guarantee to you, 99% guarantee, if you do not flip this around and you try to graph it, you're going to graph it backwards. Flip it around. It takes like 2 seconds. All right, here are some from your book. Let's see how you do. Sure. All right. Go ahead and get those started. And just for your information, I'll have the final answers up here.